session is full text indexing, and the presenter is Eric Blinn. Eric, thanks for spending time with us and sharing your knowledge.
It's my pleasure. Thanks for having me.
Sure. You can take the screen.
All right,
screen share, I say.
All right. Okay, so we should all be looking at a picture of a boat here in a minute.
The boat is there.
Fantastic. So we're going to switch over to a PowerPoint deck, and we'll just jump right into it. So I was telling Steve before everyone else joined the call that this is an older presentation that I made, and it's all still very accurate. This is not a feature that has changed much over the years. And I was going to give it a nice new modern not pass background, but I don't know. It's like an old friend, and I just couldn't do it. So I decided to put on an old pass shirt. I don't have my camera on, but trust me, I'm wearing a shirt with the pass and the key and the whole thing. And it's going to get one last run. The next time you see this presentation, if you ever see it again, I will modernize this deck. But until then, I just like it too much. I'm going to talk about a couple of things about full text indexing tonight. First thing, what is it? What is this feature? What does it do? How does it help us? What problem does it solve? We're going to look at some of the underpinnings and try to see just how does this thing work. We're going to try to see if we can make one. We've got some demos. They were working all day today, so let's cross our fingers that they work for us tonight. And so we'll make a full text index and we'll see how we use them, which is not super obvious if you haven't seen this before. And then we'll do some general housekeeping stuff related to full text to close it out. My arrow. There we go. So who am I? The name is Eric Blinn. I'm working in Cleveland, Ohio. I work during the day at Squire Patton Boggs. We're a law firm. We have 47 offices in 20 countries, including one somewhere in downtown LA that I've never been to. You can find some of my articles and other work on msqltips.com, and I do a little bit of consulting on the side through my firm, which I call Premier Data Professionals. If you want to reach out to me, I have a website, ericblinn.com. It's not updated very often as I do most of my work now with SQL Tips, but a good way to reach me is on LinkedIn, that's my profile, or on Twitter, and that's my Twitter handle. There we go. So what is full text indexing? The first thing we want to say is that it is a companion service to SQL Server. It is not SQL Server's service. It is a separate service that lives next to SQL Server, and its job is to help us find words within text columns of a SQL Server database. The original versions were based on the Windows file search program, the one you would do if you did like a window key F on your Windows machine, and it would search for files with a certain name, or you could try to search for text within text files. That same logic was basically ported and copied into SQL Server to perform the same action. And as we go through here, you'll sort of see some evidence of that along the way. You'll see little things that maybe the naming seems odd or some of the actions seem odd, and I'll try to point those out, and you'll be able to see sort of how they took this from Windows file and brought it into SQL Server. So what it's going to do, it's going to take those text columns and it's going to break them into individual words so that we can try to find them. We'll get to sort of see that on the screen here as we go. It's been available since SQL 2000, so it's been around for a long time. It had a significant overhaul in 2012 where they added some more powerful search capabilities and they added some different like delimiters, and the original version, a word was considered over when it had a period, a comma, or a space, maybe a semicolon. And then what they did is they came along in 2012 and said, well, we got things like usernames where it might be like Eric 2009. Great, well, maybe we want to let them search for Eric and 2009. And so they would consider those two separate words or also one word together. So they did some different things that made it more powerful. And that all came in 2012. And to my knowledge, they haven't done anything to it since 2012. So in 2019, where we're running all of our demos today, it's the exact same program. There are some limitations to full text indexing. The first one, probably the biggest one, is that the updates are asynchronous. Right? It is a separate service. And so you can get near real-time updates. But it's not going to be 100% real time all the time. Right? Those updates kind of get streamed, if you will, to the second service, which tries to update the full text catalog, which is what you're searching, in an effort to find those words. And again, they're generally near real time if you want them to be, but you can't guarantee it. In order to use a full text index, the table that holds that column that you want has to have a single column unique index. It's a very carefully worded statement. You don't necessarily need a clustered index or a primary key. What you have to have is an index, any index, that is single column and unique. There's a couple of additional requirements. Those are the big ones, and we'll see the whole list of them before this thing is over. Next thing, it's going to help us find words. It's going to help us find phrases, and it's going to help us find the starts of words, but it's not going to help us find parts of words, especially the back side of words, unless there's some other delimiter, like letters switching to numbers or dashes, some different things they added that would make it look like that. But if you wanted to search for the word birthday, you can do that. And you can search for birth star, and it would find birthday. But if you search for day, you're not going to get birthday. Right. So you can find the whole word, you can find the start of the word, but you're not going to find the end of it. So the searching for the word again, day, would not return birthday the way birth could return birthday if you asked for the start of a word. We'll see some demos of that as well. So how does it work? How does this whole thing work? Let's consider this pretend table that has 3 books in it with authors. And we want to ask the question, hey, let's find all the books that have the word Mars in the title. And to do that, we would have to move our eyes to the title column and not just scan the whole table, right? And not just scan every title, but every word in every title, right? Backups are overrated. SQL is, oh, Mars, we found the word Mars, right? So you can imagine it's not just a scan, it's kind of a double scan. And that's the way SQL Server would work, is by scanning the entire column, and then within that column, scan the entire value in it. And the same thing if we wanted to look for books authored by someone with the name Moose, and we would find, there it is in the middle. But again, if there was a million billion of these rows, that becomes a problem for us, having to scan essentially twice. Before we tab over that, those letters PK suggest to us that that ID column is the primary key, which would mean that it is a single column unique index, which I mentioned in the previous slide is a requirement to run a full text index. So we don't want to do this. We don't want to do this double scan, if you will. We want to be able to find that word in a hurry. So enter the full text catalog. The full text catalog would look something like this. When we bring in the full text indexing service, it makes a table. That table is called a catalog. And in that catalog table, every word gets its own row. Now, this isn't a table that we can see in SSMS. It won't be listed in the table listing. We can't query it directly, but it sort of exists in this thing we call a catalog. And you can imagine if this table did exist, it would be pretty easy for us to imagine creating this table, indexing the heck out of it, and finding the words we wanted. So if we ask the same question, how would we find all the books that have the word Mars in the title? We'd say, well, let's go select from the catalog, where the table is books, where the column is title, and the word is Mars. And looking a little over halfway down, we find out that there it is, there's our row. And that column doc ID, DOCID, I assume that's short for document ID, which I think is a throwback to the Windows file search algorithm. I think that would have been a document ID in the Windows file system, but we know that, right, that books title Mars row is doc ID 2. We're going to go back a tab, and yeah, that's the primary key number. That's why it insists we have a single column unique index, because it needs to stuff that one column value, in this case the ID, over here in this doc ID column, so you can find the row that you want. So the way this full text index works is you'll call the full text index, ask it for the word, and it returns to you this doc ID. That all happens sort of automatic. We'll see that as we go. Right? And once we have that it's doc ID 2, we can take that back to the regular table. That's a unique index. We can find the row that we want and find out that that row has the word Mars in it. And we can do the same thing for looking for the author Moose. Again, we'll select star from this table where the table is books, the column is author, and the word is Moose. Again, you could find that very quickly in a seek operation. Once again, return the doc ID 2, which is the row ID 2, and go. The reason I'm looking through my speaker notes, sorry. The reason we have a table there, which seems maybe is an extraneous thing, is that when you build one of these catalogs, you can put the indexes for many tables in them. And so might not always say books, right? You could, if you had a second table of short stories, there might be a table for short stories, which has its own doc ID and then columns and words. And it keeps track of some level of sequence. That's what that's for. Those are useful if you want to do something like a near search. You want to know if the words are near each other. So it keeps track of some sort of sequence to indicate that the word might be near another word. All right. So that's what it's going to do behind the scenes. If we want to use it, well, we have a couple of steps. The first, it has to be installed. It is not necessarily installed by default unless you checked every box and then did the install that way. So there's a separate checkbox during the install to install that specific service, and then the service has to be running. I don't think it's super uncommon for folks to install every checkbox and then to come and stop the services they're not using. So if you'd like to use a full text index, you'll have to make sure it's installed and then come down to your service list to make sure it's running and preferably be automatic so that it will come back when you restart. That's it. Adding those two pieces gets you going. So if we want to make a full text index, yes.
Quick question.
Yes.
In case of you trying to add a full text search, would that cause a downtime to SQL Server or not?
I've done that install, and I don't think it asked me to restart at the end. It will certainly not start and stop your SQL Server service. I'm not 100% that it would ask you to restart. It might, but you could certainly do the install and then let it sit and do the restart later.
Got it. Thank you.
Yep. Great question. Thank you, Steve. If anyone else has a question, I think you might be muted, and if you are, you can put it in the chat, and Steve will interrupt me at a good spot and ask it. If not, I'll open it up, the whole thing up at the end, and we can do that. All right, so we've decided we want to make a full text index. We have a text column that we've decided we want to search, and we want to be able to search it quickly. So the first thing we need to do is we have to make sure that our table is a proper candidate table. So number one, does our table have a single column unique index? Right. Number two, does it have a column that's searchable by a full text index? So it can be a character, a variable length character. I run there max. Max is great. You can search a max column, where I think I'm almost certain the table I did was a max, so that's not a problem. And whether it's ASCII or Unicode, doesn't matter. That's all fine. When we make the full text index, you can choose any number of columns to go in the full text index. And when we do that, the order doesn't matter. Right? It's not like a regular non-clustered index or a clustered index where the order in which you type them matters. It doesn't. It's simply a binary decision of, do I put the words for this column in that catalog or not? You can only have one full text index per table. So it's important to include every column you might maybe want to search in that table. Or excuse me, in the full text index, I should say, so that it's there. You can't decide later to add a column, add a second index for another column. You would have to drop and create that full text index with the additional column. Okay, so we've identified a table and a column or a group of columns we want to search. The next step is to create a catalog. The catalog is sort of an empty table, right, that we saw in that a couple slides ago. It creates an empty one. I sort of call this like a throwback statement. Way back in like SQL 2000, maybe even 05, when you said create a catalog, SQL Server put a file on the disk right next to your primary MDF file, and it started putting the words in that file. And I guess that's a throwback to when it was the Windows file search. So in the early days, they actually made a file, put words in it, and then searched that file. Starting in, I want to say it's SQL 08, but certainly anything newer, 2012, 2014, 2019, right? When you do create catalog, essentially nothing happens. Like nothing happens. Somewhere in the background, some kind of create metadata thing happens, but nothing happens on disk, nothing happens anywhere. It's a statement that I think is almost silly. The best practices suggest we should make one catalog per table. So I'd like to see in a future release that just creating the full text index creates a catalog and puts my full text index in it. But that's not what it is. We have to create the catalog for what nowadays is kind of like no particular reason. The next step is where we create the actual index. Right? We've picked a table, we made a catalog, and now we put the index in the catalog. We have a couple of options available to us. The first one is whether you want to build it right now or whether you want to build it later. We know when we build a non-clustered index or a clustered index or even a column store index, as soon as you run that create statement, the SQL Server engine goes nuts, reading all those rows, writing them into the index. You can do that on a full text index. Or you can define it and say, look, here's the columns I want in it. Here's the table I want to do it, but I'm not actually going to do it. Don't actually do anything yet. And you can say, look, wait until 2 in the morning and then populate them. That's an option, and we'll see both options when we do the demos. The second is to whether you want to do continuous updates, right? That's I mentioned that service constantly sort of accepting a stream, if you will, of these changes, and constantly updating them as quickly as it can, hopefully near real time. Or whether you want to schedule that, where you say, look, I'm only going to do updates at some late night in the morning. At 2 in the morning, I'll update my full text catalog, and until 2 in the morning tomorrow, not going to happen again. So you'll have to decide which one of those makes sense. I've seen some people online talk about scenarios that make sense for the scheduled, but in my practice, I've never used anything but continuous updates. But it's an option, and I'll show that option just in case somebody has some interest in that, and see what makes sense. Enough slides. We're going to switch over to Management Studio here in a second. And what we're going to do is we're going to make some catalogs, make some indexes, try to see this stuff in action. There's a couple of new functions we can use, and some DMVs that'll help us monitor those creation. All right. Here's to this. All right. I hope everyone can see this all right. I know some of those results are small. That's not going to be super important for what we do. Really what we want to see is that code. So what we have, right, is I've created this table called Great Documents of History. What I needed was some text that was not copyrighted, so no one could possibly complain, that was long enough. So I've taken these 9 famous documents of history and spit out their text over here, and we're going to see it's a nice long piece of text, something you wouldn't want to scan. Right? So we're going to come in here, and we're going to just run select document name from there, but I want to find the word freedom. Right? So I'm just going to my great documents, and I'm saying, hey, the document text is like space, freedom, space, because I want the word freedom. And if we come over here, we'll zoom in. I'll tap that, and we'll zoom in. We can see it. Right, as expected, it does a clustered index scan, meaning it went to every single row. Right? And the way we did that, we can be confident that not only did it look at all 9 rows one at a time, it also went through the entire text as sort of scanning across, checking characters 1 through 8, then 2 through 9, then 3, right? It just scan, and a pretty painful operation for it. Right? So that's a scan. We don't want to scan. We want to do better. We want a full text index. So we come down, and turn it off there. Step 1, we have to create a catalog. So I'm going to run this line, and again, nothing happened. If this was SQL 2000, a file would have appeared on the disk. Instead, essentially a piece of metadata was dropped in the primary file group. This question has come up before. I don't think you can choose to put it anywhere but the primary file group. I say that because if I tried to say on primary, right, it doesn't like that. If I tried to run this, that's a no-go. So if it won't let me force it onto primary, it certainly wasn't going to let me pick any other file group. So if you're the kind of person who doesn't use the primary file group, full text indexing might be a challenge for you because you're not allowed. Next step, right? We have our catalog. We've chosen the table. We've created a catalog. It's time to make the index. So much like any other create index statement, we just have this word full text in there, right? So instead of non-clustered or clustered or column store, we just say full text. We put it on a table. We're going to do great documents of history. Again, once again, the order doesn't matter, right? It's a binary decision. Do I want those columns in or not in my full text index? Great. And here's where it becomes kind of different, especially different, I should say, from other things. We said we needed a single column index. We have to tell it what that is explicitly. It will not find it. It will not guess. It will not assume. You have to tell it, this is the single column unique index I want you to use to make this work. And I have to tell it which catalog into which to put it. Well, I just made the one, so we're going to use him.
Eric, but yes. I think you're creating it on 3 columns now: document name, primary author, and document text.
Correct. All 3 of those are in the index.
Right, but your was against 1 column. Now you're actually going to be looking through 3 columns. So you're basically making it more complicated.
Well, it's going to allow me to search more columns, right? So that's a fair point, right? So if we come back, I'm going to switch back to this guy. And let me just stick this back up there, right? So in this one, I have 3. So this is that sort of pretend one I did, right? So I'm going to have more rows in my catalog, right, that allow me to search. And you said I had 3 columns. This one has 2, title and author. My catalog will have many in there. And when I do my search, I'm going to tell it which column I want it to find those words in.
Okay.
So this one's going to have, when I do the when I do my catalog, it's going to have the table is great document of history, and it's going to have the column as document name, and then a bunch of words. And then more rows that say, hey, great documents history primary author is, and then more words that say great documents of history, document text words. They'll all be stuffed in there in that one very large catalog. And when we won't be querying it, but essentially the tool will be coming in and saying, hey, go to the catalog for great documents of history, find the table great documents of history, find the column document text, find the word freedom, and then bring me back the unique ID of this so I can go find it. But by putting more than one in, it allows me to search. Instead of just being able to search document text, I can search any of those columns. But I don't have to. I could.
Okay. All I'm saying is that you did a lookup for like on one column. Now you're doing a full text index on 3 columns. So you're basically making it more complicated.
Well, because I want to be able to search the one column. You're right. I could.
Yes.
If I did this, this would solve that query, but only that query. If somebody comes by tomorrow and says, hey, I want to find anyone with the author Thomas Jefferson, my index would no longer be useful to me. My full text index wouldn't be.
Okay.
Right, but you're right. You are correct to say that if I was to remove those 2 columns, it would still solve that one example query above.
That's not what I was saying. What I was saying is that you're trying to remove the scan, and your like is only going against 1 column. Full text index allows you to do more because you can do now 3 columns, and what you're probably going to be showing is that the performance is much better, but not against the same 1 column, it's against 3 columns.
Oh, that's true. Yes. So I could search for that one word in the same 1 column or in all 3 columns. And again, it would, it would still be significantly faster than even the one scan against the 1 column. That is a fair statement. Yes. Right. Yes. When I use the full text index to scan for that same word in all 3 columns, it will be significantly faster than just liking, which we did above, all 3, any 1 column. Yes. All right. That's a great point, and I don't really mention that specifically along the way, but that is a very fair point, and we'll see that in the demos kind of on accident. All right, so we're making our index. We put 3 columns on it. We referred it to the key index that we wanted to use, which is the single column index, and the catalog we wanted to put it in. And the next piece is this change tracking auto. This is where I'm saying I want you to automatically update as the rows change. That's the sort of keep it near real time, if you will. So we can run that statement, and it's going to create my full text index right now. It's not a very big table, so it doesn't take terribly long. There's an object property that most folks don't use. Its table has full text index. We're going to run him, and we're going to see this table gets a 1. That's a 1. There's only 1 per index, so that'll never say 2. It's either going to say 0, you don't have 1, or 1, you have the maximum 1 you're allowed to have. Right? So that's a yes, no sort of a thing. And it might be useful if you're writing some code that's querying against tables to decide whether it has a full text index or not before you decide maybe to undertake a search that you might want to do.
I got a question on the create full text index syntax.
Yeah.
I understand that the catalog cannot be in a different file group, but can the index be on a different file group?
Let's see. I don't know where. I don't think so, because it tells you where to put it in the catalog, and that catalog is where it goes. I don't even know where I would put such a thing, like an on primary. I don't think that's allowed. Yes, you're not. I don't think you get to choose at all. Again, that's a bit of a throwback to back when they actually put a file on the disk. But none of these statements that I've seen allows me to type in a file group, so I don't think you get to choose. I think it goes in the first file in the primary file group, and that's it.
All right, thanks.
It comes up from time to time. I know it burns some folks, but I've never figured out how you can put it in any place other than there. Just because there's any of the places you would do it, it doesn't allow you to type in a file group name. Right. We're going to do a second full text index on a table we're not going to query during the demo, but I put it in here anyway. So it's great quotes of history. Right. And this one we have 2 columns, speech name and speech text. And I'm going to use the primary key again, because that's the most common scenario we use. And I'm going to break a bit of a best practice, and I'm going to put it in the same catalog as the other table. You generally wouldn't do that, but it's not going to hurt us, certainly not in this demo. And one change, though, change tracking is manual. It will only build this index when I tell it to explicitly, and not on its own, not even when I run it right now. It's just going to define this index and stop. Interesting. Oh, it doesn't like that. Oh, it doesn't like that at all. So what does it say? It says PK great quotes of history is not a valid index to enforce a full text search key. A full text search key must be unique. I think we knew that going in. Non-nullable. Single column index, which is not offline. All right, I think some of that was there. It can't be not defined or non-deterministic, blah, blah, computed column. Can't have a filter. Right? And then the other big one that I don't mention earlier is that it has the maximum size of 900 bytes. So that must be as wide as that doc ID column is on the catalog. So you can't do it, even if it's unique non-nullable, but some big nvarchar 4000, that's not going to fly. So it tells us to please choose another index for the full text key. I like to put this up because it's maybe my favorite error message in all of Microsoft SQL Server. It's so clear. You know exactly what you need to do. And so we need to find ourselves another index. So let's just take a look at this table. And first thing we see, PK Great Quotes of History has 2 columns. So that's a no-go. So what else do we have? We have an ID. That looks promising. It's only 4 bytes. It's not computed. It's not nullable. And we see that it's an identity. That's a winner. That is if we had an index on that column, it would work. So let's make one. So we're creating a unique non-clustered index, which I'm going to call alternate key quote ID on that ID column. And I did that to show, again, it doesn't need to be a primary key. I've seen a lot of people writing online and documentation that says you have to attach it to the primary key, and you don't. This is not a primary key. It is not a clustered index. It is just an index that is 1 column. That's the rule. So now let's try this again. Same thing before. We're creating a full text index on quotes. There's my 2 columns. Now I'm referring it to this key index AK quote ID, the one I just made. Same catalog and still manual tracking. I'm going to run this once. Beneath it, this is that object property, and we see that he does not have a full text index. That's a 0. And if I run them, now it has been created, and that returns a 1. So again, now we see that both tables have a full text index on them. We have some DMVs that tell us about things. Here's our list of active catalogs. We have 1 catalog. It's online and it's available. There's some other stuff here. That's really the piece we want to see, right? And there's nothing currently active. Fine. Here's a DMV, FTS index population. It lists all of the indexes that are currently actively populating, right? And we see there's 1, the Great Documents of History, which is an auto-populate. One thing that kind of catches some folks off guard, this status description says starting and the completion type says none. It will forever say that. Unless you manually rebuild that index, it's going to say that forever because it has started doing the automatic updating. It's sitting here waiting for a change that I'm going to tell you will never come because I'm not changing that table, but it's waiting for it. And it's never done. It's never done because it's never done waiting for you to maybe make a change in the future. So that kind of looks like it's not ready to go, but it is in fact ready to go. That's what this means. I wish they would maybe describe that a little different, but it's not done and it's never going to be done, and that's okay. Now, the great quotes, right? We told him to only run manually when I tell him to, and this is the statement that would do that. We're going to alter the full text index and start a full population. So I'm going to run that and try to really quick come catch him. And we see now there are 2 populating. The one that's doing the automatic, which is the one that we built first, that is constantly keeping itself up to date. And then this guy who's only doing the full, and he will in fact finish. And that table is very small. I don't think there's any rows in it. And in fact, it's done. You see it went away. So it was only in that DMV while it was actually running. So if you're doing those fulls, you can either choose to do a full every day, week, month, whatever makes sense, right? And the other option, sorry for that ding, and if you guys heard it, it's warning me about this event that I'm sitting in. The other option is to do an incremental. So if you have a timestamp column, the full text indexing service notes that timestamp value when it did the full, and it allows you to come back later and do an incremental population with just the changes since last you were here. It can be very useful, and it's a good reason to maybe slap a timestamp column on there if for some reason you're not doing automatic, consistent updating. And the other one that I've never seen anyone use in my life, but I mention it, is that along with incremental population, you can do an update if you have change tracking enabled on the table. and it's able to, the full text indexing service is smart enough to go to the change tracking table, find the changes since last you were here, and just index those. So if you have an incredibly large table and you're only going to do updates overnight, it makes sense to use one of those two options. So you don't have to rebuild the whole table every night, just pieces and parts. And it's I've never used one of those in practice. I've heard of people doing it. I don't know. I mention it because it's real and it's a thing you can do, but it's an incredibly unpopular, in my opinion, feature. We have our stuff. We have our full text index. We're going to now search for the word freedom. We have a full text index. We think it's going to go real fast. And wouldn't you know, look at that. It's not fast. In fact, it still did a clustered index scan. That's not what we wanted to see. So the first time I built one of these, this particular piece flummoxed me a little bit. I was so confused. Why the heck would it not be faster? And it turns out there's a reason for that. Some of you who have seen this before know what's coming. For anyone who's new to full text indexing, you're about to learn something kind of neat, I think. Full text indexing will not work with your normal, usual operators. It doesn't work with equals. It doesn't work with not equals, less than, greater than, in, not in, like. None of those work. You have to use one of these 4 operators. Contains or contains table, free text or free text table. The 2 across the top, those would be something you would put in your where clause. They will return a simple true or false, right? So contains is for exact matches. So you'll ask it for a word or a phrase, and it will come back with yes or no. You found the word or phrase verbatim. Free text is kind of what we call fuzzy matches. So it looks for things like if you search for the word run, it might say, well, I'm going to look for run, runner, runs, ran, running. Right? That makes sense, right? And it's trying to find things that are similar to what you want that might be close. It's kind of some of the stuff Google does for you sometimes. Not nearly as powerful, but kind of in that vein. The 2 table versions, same thing, one for exact matches, one for fuzzy matches. And what they do is they return not just a Boolean yes or no, but like a rank, right? So it's looking for, is the word early in the text? Is it often in the text? Is it used many times? And tries to try to put things that are maybe more relevant near the top. And right, we can select from them. And these don't make sense by themselves. We're going to go see some demos of those to see what they do. And one note, if you want to go between them, right? So you don't want it maybe a verbatim exact match every time, contains. But you also don't want all of the fuzzy match stuff where there's all kinds of synonyms. It does, forms and plurals, and you can kind of get halfway by calling contains with some extra features to get it just a little bit closer to free text, but not being quite as wide open. We're going to see that in the demos too. So let's switch back, and we're there. All right, so we were looking for that word freedom, and it didn't work. So what if we instead said, well, I don't want to get too far ahead of ourselves there. Same thing, select document name from great documents of history, but now I'm going to say where contains, right? No equal sign, no less than, none of that, just the word contains. And then what column do you want to search? Well, I want to search in document text, this column. And then we come back and say, hey, what word am I looking for? Freedom. So this is a contains function. So you tell it, what column do I want to search? What word or phrase do I want to find? And if we run that, our query plan should look significantly different. And in fact, it does. Right? The first thing it says is, I did a table valued function full text match. Hey, that's pretty good. And if we float over that guy a little bit, come down to the bottom, we see that what it found for us was, hey, there's our buddy doc ID. Right? So it went to the full text index. It said, all right, I'm looking for the word, or excuse me, I'm looking for the table, great document of history. I'm looking for the column, document text, and I'm looking for the word freedom. And it came back with several doc IDs, the group of doc IDs that were useful. And then it took those doc IDs, right? There it is again. It took those doc IDs and it ran them up against the IDs and returned the rest of the output we asked for, in this case, the document name. Right? So those are the 2 seeks we thought we would see, having seen those 2 sort of virtual tables on the earlier slides. And that's what it did. Went to the catalog, looked for my word, found the doc IDs, which are the unique identifiers, and used them to look up the rest of the data on the table. Right? And we're going to find that especially as the table gets bigger, that is significantly faster. I don't know that I showed that specifically. One thing I noticed is that the query optimizer here, right? He suggests that the full text index is worse. Notice it's kind of tough. I know it's a little small. It suggests that the like is 31% of its effort, and the contains is 69%, we're going to find that's not accurate. That is not a fair assessment. The full text index is significantly faster, especially as the text gets bigger, as the table gets bigger. And we'll see where we are at the end. We can do some other metrics to look at that. All right, what Steve had mentioned earlier was that we can search one column, but he says, hey, you can search all the columns just as fast, and you pretty much can, right? If we replace that word document text with a star, it searches every column in the full text index. I don't know of a way that with this shortcut that you can do, less than that. In this case, there were 3 tables, or excuse me, 3 columns. So I can do 1 column, and I can do 3 columns. I don't know that I can do 2. I don't know how you do that without doing 2 contains statements, but you can do 1 versus all, and they both run pretty quickly. Right. You can imagine, based on the way that catalog table looks, all you have to do is just say, well, the table is great documents of history, and the word is independence, and you ignore the column because you don't care. You just want to know if that word was found. And we see that we get 1 more on the star because the word independence is actually in the document name. So we searched the document name and the document text in the second one, where we only search the document text on the first one. Right, it's a nice shortcut to search for that word anywhere in any of the columns. We're going to take our first look at FreeText. So this one is going to look for the word help verbatim, only help. The second version, where we say FreeText, and that's the only difference. That's the only word that's different, is that word. We in fact get 2 results instead of 1 result. So this second one, Brown versus a Board of Education decision, it must have had helps, helped, helper, something like that. I don't know what word it was that caught it, but there was something more than you found with contains, and it was not the exact word help, but it's probably useful. If you decide it's not useful, if you want to find that word verbatim, then you don't do FreeText. Right? But that's all that is. It's just a matter of changing words and presumably, hopefully, getting more results. We can look for 2 words. Right? And the obvious way, what I've shown you so far, is you would say, look, I want to do contains this word, which is, I don't know, some kind of god that shows up in Hammurabi's code, and this word. Right? And you would find both words, but that's going to be a little bit slower because you got to run that contains function twice. You can use this tilde, which is a shorthand for an and. That means both words, and it can be more than 2 words. You can do whatever, but it's an and. It's an and both words. And so those 2 are essentially the same as far as our coding is concerned. We would think the second one might be a little bit quicker because you don't have to call the function twice. The full text index service is able to respond with a single call, looking for both words. Right, so a tilde is shorthand for and. We can search for a phrase. What I like about searching for a phrase is that we get to use the double quote. SQL Server doesn't often give us an opportunity to do the double quote. We almost always use single quote, but here we get to use it. So we're going to search for that, and we find 2 different documents use that phrase, he shall receive, right in a row verbatim. So I mentioned we can search for starts of words, right? So if we search for the word conf, we're going to get nothing because the word conf isn't the word. We didn't find it anywhere, but we can say double quote. There's our buddy double quote again, and a star at the end. Notice that's not a percent, right? We're thinking Windows file search algorithm, so it's not a percent sign. It is a star. And we'll find the articles of confederation, CONF, there it is. So it found the start of the word, and it can still seek. It can seek because it can still go through that catalog, find its way down to the C's, CONF, and it can still seek to that. Right? And it would work. If I typed a star in here, it'll work, okay? And you'll get a result, but it's going to be significantly slower. I have 9 rows, so we don't see it on our screen here, but it has to go back to scanning when I do the double star as opposed to that. So just like you can do a like something percent and it can seek, but like percent something percent, right? It has to scan. It's the same here. So it will help you quickly find the starts of words, but it will not help you quickly find parts of words. Like I couldn't look for ration, R-A-T-I-O-N, the last few words of confederation. That's not going to be useful for us. It won't find that. At least not quickly. It would do it with a scan.
Eric?
Yes.
There is a question. Can you replace field name, document name with star or columns? I think you're probably better reading it.
Let me find my chat here.
Yep.
Where am I here? I want to go there. Can you replace field name, document name as star, all columns? So yeah, we can do that. We can do any of these. So you could do the same thing here. Any place you see a column name, you can put a column name or you can put a star. And so we see, in fact, there you go. Conf was found several times, not just in that title, but it found 4 more objects by saying search every column in the documents of history. And to be clear, that's every column I put in the full text index, which in this case is all of them, but it doesn't have to be all of them. It's everything you put in the full text index. Can I do a select star? I can do a select star. And let me go back over here. Or, oh, no, come back. That's not the one that works. This is the one that works.
So I got a question with that example. So that contains star means search all the columns from the full text index. Is that what it means?
Yes. So star means that search every column in the full text index, which if I go way up here,
Right.
is 1, 2, 3 columns, all 3. So you can do 1, you can do 3. I don't know how you can do 2. Again, without doing some kind of an and or an or with multiple contain statements.
Gotcha. All right. Thanks.
Yep. So we go back here. Where were we? We were on conf. Yeah. So when you do a select star, I think what we might be looking for here is that execution plan is going to have. Well, this one's searching on the clustered. If so, when you do a select star, we know that the full text value returns the doc ID, right? And then it's going to take that over to the index we told it to. In this example, it's the clustered index, so it found all the columns. Right? If I had rows in and we did one against that great quotes of history, where the key index we gave it was a non-clustered index, we would in fact see the table valued function from the full text match, followed by the non-clustered seek, followed by a key lookup, where it had to go a 3rd layer back with the cluster to go get the rest of those columns. So you could see that go 3 layers deep. I don't know if maybe that's where you were going with that question. Looks like Ashish. Does that get us where we were trying to go? Yes. All right. That's a good question. It's a great question. Yes, you can go 3 seeks deep to get that answer. And it would work on the other one if I had rows. All right. These are good questions. Thank you all for going. Oh, and audio's off. Hopefully your audio clears up. So those were all the where clause, right? Every one of those appeared in the where clause, and they returned a simple yes or no. Do I show the row? Do I not show the row? Period.
Eric?
Yes.
Quick question.
Yes.
So what if you need to do text search on, I'll give you an example of where I used full text search and I couldn't find a way to do it right. So if a customer service person writes in the notes on customer order fraud, and I have a computer column that looks for the word fraud, for the keyword fraud, and makes the is fraud 1. But what I found later, and again, this was not significant, but still I couldn't figure out how to do it, is some of the customer service people in their notes, they write fraud, and then they realize, oh, this is not fraud. So they basically, no fraud. So basically, how can you accommodate for the no before the word? Basically the opposite, if it's even possible.
Just thinking, I think I would want to find out if I don't know, my customer notes, right? So my cust notes, right? And I want to find the word fraud. But I would also say, I think I can say not, right? Let me put a star in this so I can actually run it. Right? Can I do as long as I can I do a not? Man, awesome. So if I were to say that you contained fraud, but you also not contains
Got it. Okay.
the phrase what you said was like dot not fraud,
not
or something
fraud,
like that.
yes.
Right. So now I could come along and say you need to have the word fraud, but you can't also say not fraud. That should get you where you want to go.
Got it.
Use
Okay.
the phrase for the second side.
Okay, cool. Thank you.
So those are all the where clause items. We saw some contains. We saw a little bit of free text. Hi, Jim. Welcome to the event. So now we're looking at contains table. This looks a little different. Notice it's in the from clause. There is no word where anywhere in this query. So we say from, and we don't put our table name. We put contains table. And then we give it the name of the table. Great documents of history. This star is the same as up here, right? It's a column or all the columns. And then a word. Let's run this real quick. we're going to get back exactly 2 columns. We will always get back exactly 2 columns. The first is the key. We need to know that that is the column ID. It's not going to tell us. We need to know what that is. It will always be called key. It doesn't matter if your column is ID. It doesn't matter if it's a varchar. It will be called key. And then a rank. It's a number between 0 and 1,000. And bigger is what we would consider better or more accurate. So that means that the word appeared earlier, appeared more often. Right? It tries to help you push those to the top. Right? We almost always use those. Hi, and welcome to Lori also. Glad you made it. So we're going to do that same thing. There's our contains table, star and freedom. Awesome. Then we're going to join that right back to the table. It's almost always used. I can't imagine where you wouldn't, but it's almost always joined right back to itself on the column key, because it's always called key, equals the column. We need to know this. It will not tell us this. We got to figure it out ourselves. If you have multiple indexes that happen to be, you have a, I don't know, a social security number that's unique and an employee ID that's unique and an identity that's unique, you got to know which one they picked, so you know which one to join back to. So we're going to join that guy up, and we're going to order it by the rank descending. So we had those 5 results, and now we've got our 5. Our 5 results. We've put the biggest, most common ones on top. And we have something that's starting to look kind of like what might even be like a Google search results, right? And we've got our results. We've got them ordered top to bottom. We found that word freedom in those documents. Right? That's how we do a contains table. We can do a FreeText table on the same thing. The first thing we'll notice upon calling the exact same query, right? All I did was change the word contains to FreeText. Everything else is identical. First thing, the numbers are bigger. That's the first thing I always noticed, is that whenever you do FreeText, the numbers are going to be bigger than contains. I don't know why that is. I don't know how they did that logic. Someone showed me the code once. They'd found it online, and I didn't understand it at all. But it does these different things to determine the rank. And again, it's things like being there earlier and more often. But now this is really starting to look like something I might want to, and I wouldn't probably show this to the user. Maybe I would, if I wanted to know how strong my thought was that this was the right choice for them. But I would want to certainly show them those in a reverse order when they search for that word freedom, that they found it far more often up top. Here's another one for contains table. We're looking for the word God. So Hammurabi's code must have it a lot. I put this one in there to show they're not always 1s and 2s. There's a pretty significant drop. Maybe it makes sense in some scenarios where you say, look, if I got a big 32 and a 10, maybe I don't even show them the 3s and the 2s. I don't know. You got to think about what you want to do with that information. But that's a scenario where you can get a significantly larger number, suggesting a strong likelihood that's the document you're trying to find. Eric, can I show the execution plan? Yes. Yep. So here's the execution plan. It should look pretty similar as before. So here's what outputs the score. I haven't looked at one of these in a while. So it's outputting the score from the full text search up here. And then it does I'm surprised it doesn't show the doc ID. It clearly went and got the doc ID. So here it is again. And then we do the clustered index where it returns the doc ID, searched it against the ID to return the document name. I'm going to go back. I'll show the top half again. It doesn't say doc ID, which I think is strange. Clearly, that's what it went up there to get. But it's showing us that it only returned. Oh, no, sorry, it's right there. I wasn't paying close enough attention. It returned the doc ID and the score from the full text match. And notice that's the same thing. It just returned one extra value. It's otherwise the same as the contains and the free text without the table. There's some neat things we can do, right? We've seen looks for words. We've seen us look for phrases. We've seen us look for starts of words. We can try to do some interesting things like find words near each other. The near keyword means and. One thing that kind of confused me when I got into this, near means and. If it has both words, it will be in the result set. Doesn't matter if they're not actually near each other. It will be in the result set if they're both there. And if they're far apart, it just reduced that rank considerably. If you do a near in your where clause, it's binary. It either says yes or no. And so it will say yes, even if you pick the first word and the last word and they're 10,000 words apart, it's a yes. They're both in there. It treats it like an and it will show it to you. So if you're going to use the near keyword, I know this one just burned me when I was first learning this. So I couldn't figure out why it kept showing me these two words that were not near each other. And it's because they're both there. It just means and all it means is and are they both there, and then rank it based on how close they are. Right? So keep that one in mind if you want to use near. It's one that comes up a lot when people search, when they're trying to find things like, fraud near telephone or something, that they want to try to find that someone's talking about, telephone fraud, wire fraud, something like that. So you want to definitely use that in a table option. And that's a scenario I would consider if I was doing something with a near clause in this. I would remove anything if the rank was 0, because that means to me that they are, I know they're both there, but they're so far apart, it's surely not what you're looking for. Here's two words that are nowhere near each other on purpose, right? And it gives us a 0. And here's two words that are right on top of each other. It's the same query. We're doing that contains table. We're looking for two words near each other. And so when they're super far apart, good question. It's coming up. And I get a 2. So we can see that in the contains option, on the contains option, you get low numbers, but a 0 certainly means very far apart. Anything above 0 means at least kind of close to each other. And the question came in, how do you escape the near word? And I'm going to remind myself, I want to say it's a backslash, but I'm not super sure on that one. Come back. Nope, it's not that. Give me a minute. I used to know that, and I don't remember it off the top of my head, but you can escape the word near if you wanted to actually search for the word near.
Question, is that near the same as that tilde that you showed us before?
So tilde means and just means that both words are there. And near means, it means just like a tilde that both words are there, but it also means adjust that rank column, not based on them being both there, not based on them being there often, but based on them being physically in close proximity to each other in the text. So it just adjusts the rank. So it's a type of and. Maybe think of it that way.
All right, thanks.
Yep. Okay. So again, just like I mentioned before, I have these two words that we said were nowhere near each other, and these two words that are right on top of each other, and they're both, when we put them in the where clause, it just means yes, they're both there. So even though one of those are two words that are near each other and one of them is not, it still both just means yes. So it's a keyword that's used pretty often, and it kind of annoys me that it doesn't just say no, but it doesn't. So I mentioned that contains looks for a word super verbatim, right? And FreeText does all kinds of fun, fuzzy logic, and we can try to meet in the middle sometimes. And this is how you would meet in the middle in some scenarios. So the first query here says, hey, I want to go to that great documents, and I want you to find the word watch in any of the columns. Great. This one says, I want you to find the word watch, but I want you to use different forms of the word. Watch, watches, watched. And so while the first query finds nothing, the second query did find something. And it didn't do all of the fuzzy searching logic. It just did one kind of that searching, which can be useful if you wanted to, only look for, tenses or plurals or synonyms, something like that, without doing everything. Speaking of synonyms, a thesaurus. So inside your full text indexing installer directory are a whole bunch of XML files. Each one is a thesaurus file that you control. So let's take a look at the ENU, English United States. That's the one I'm using today right now. We'll go into Notepad++. I don't know if I can zoom in on this or not. Well, I can do this. Now, if these look silly and old, it's because they are. And it's because, like I said, this program has not changed significantly in many, many years. And these are the examples that you get. When you install SQL 2019, if you installed full text indexing, this folder exists, and these examples for Internet Explorer 5 are there. Bravo. Right. So there's two different things we can stick in here. All right. The first is a substitution, which means you just have straight up synonyms. And so in this example, if anyone searches for Internet Explorer, it will find Internet Explorer. Without asking you, it will go find IE and IE5. And the same thing down here with run and jog. It treats them the same. The pattern and substitution, these replacement ones, right? Because if someone searches for NT5 or W2K, I'm not going to search for that. I will instead search for Windows 2000, right? So it just totally says you basically can't search for that word. You could have some fun with somebody if you wanted and put a whole bunch of patterns in here and substitute something totally different. And no matter what they search for, if it's in that list, they're going to search for a totally different word. So we're going to add something to that. And what we're going to add is our own expansion for some words we might find in here. And we'll see them here. So what I'm going to do is I've got the words representative, delegate, and senator. For the purpose of our searching and for the next few examples, what I want to see is I want to see what happens if I search for any one of those words. I really want to see all those words. So we're going to jump back into here, and I'm going to paste this in. So I've added a new expansion, representative, delegate, senator. Treat them all the same. I'm going to save that. Now, at this point, we have an option. We can either restart the full text indexing service, which sounds kind of dumb, or much better, we've load the full text thesaurus for the language 1033, which is English United States. So I'm going to run this, and that's going to reload my new thesaurus. Great. So let's run something. I said it should treat both of those words exactly identical, and we see it does not, because contains is a verbatim search and does not respect the thesaurus or any other fuzzy searching. So even though we told to treat those the same, it will not, because we did a verbatim search. What we need to do is I want you to tell it, I want you to respect the thesaurus, nothing else, just respect the thesaurus and search for delegate and search for representative. And since we told to treat those two words the same, we get the same results. The same 4 results on both because we told it to treat both words the same. This can be useful if for maybe a common typo. Like, I don't know, if I was doing this fraud one, I would probably put a substitution like this for FRUAD for fraud, so that if they misspell it, you can catch it. Maybe you put fraud and cheat and steal and lie or something like that, and those. I did this in Baltimore, and the guy said, we have this issue where I need to find out how many business meetings these guys have, and some of them type in meeting, and some type in opportunity, and some type in, sales call. And I was like, oh my gosh, this is a perfect example. You can treat all of those as the same word when you're doing your search, and find all the times people were doing sales call, sales meeting, right? And find those and treat them the same no matter what they typed in. Again, FreeText does all of those things together. It does the forms of, inflectional, it does the thesaurus, it does all those things. So we would expect these two to also return pretty close to the same results. We actually get a 5th one on the bottom. So there must be something, maybe the word representation, something in there it found that it liked that it didn't have. We get pretty similar results using FreeText. There's just one more word in one of these that that caused it to pick up. I'm guessing something like representation, like I said. We've got a bunch of different stuff we can do. I'm just sort of scratching the surface. There's a billion things you can do, but they should give you a pretty solid taste for the different sorts of things you can search and find using contains, FreeText, and their table alternatives. I'm going to jump back here. All right, I wanted to mention a couple of general housekeeping items. Then there was an unanswered question about how to escape a near. I don't think I saw that in the chat. We'll look that guy up. And if you want, we have a couple of minutes. We can look at some of the performance metrics. We saw that the one based on the plans was no good. We can look at some of the different metrics and see how much faster it might be. I wanted to mention those catalogs. They're in the MDF. And I say the MDF because most people have one. If you have many MDFs, it's going to go in the primary file group. And again, like it came up earlier, I don't know that you can move it. I've never figured out a way to move it out of primary. Because they're just in the MDF, and again, if you're still running SQL 2000, I hope you are not, but if for some reason you were, it's not there. It's a separate file, and you have to do things with it. But since most of us are running something, hopefully SQL 08 and newer, it's just going to be in the MDF, which means it's just backed up. You don't have to do anything special. It just follows along like any other index. You don't have to do anything like permission-wise. It just is. As long as you call those functions, it will use it. And you don't need permission to call the functions or anything like that. It's just a different operator. There is a reorganize option and a rebuild option. It's something you should do. If your index feels like it's getting slower or anything, you can do that. Maybe something you just go in once a week and just do it. It's a very simple command. It's alter full text catalog, give it the name, and then a rebuild or a reorg. Very similar to altering a non-clustered index. Super simple command. It's available in books online. I don't think I put it in the demo anywhere, but it's a basic thing. I don't think, though, that like if you're using the Ola Hallengren thing, I don't think he considers full texts. Maybe don't quote me on that, but I don't think it's part of it. You'll have to do that yourself. The last one I put in here, it's interesting, that last bullet point. I saw a demo of it once. I've never seen someone do it in practice, but you can put a full text index on a file table, which we know is a virtual table that is in fact pointing to files on disk. And because it's based on the Windows file search algorithm, you can point, if you're putting things like text files or XML or PDF or anything it knows how to read, you can in fact use your full text index to find the words in the documents inside your file table. So it can make for a pretty powerful searching tool if you're using file tables. But I don't know. I don't put it in the demo because nobody uses it. But I saw it once. It works, and it's kind of neat. All right. That's the end of my presentation. I want to see if I can get an answer. Let me check the chat. And I want to see if I can get an answer on how do I escape that word. I'm going to look over here. I'm actually Googling it. I'm kind of embarrassed. I used to know this years ago.
I guess the question now is when to use, which one, right? I mean, when to use FreeText, when to use contains, because it seems that contains can be powerful as long as you use all these different, inner functions, where FreeText uses, I guess it's all embedded based on what I see here. So the question is when to use which syntax, best practices.
So I would say for the most part, in most scenarios, especially if you're doing something like a search page, you're going to use the table options far more than the binary options. And I would say that for the most part, you're probably using FreeText. I would say I would lean towards that in most scenarios, unless there's a situation where you say, look, I only want to know that specific word verbatim. Steve mentioned earlier he wanted to find the word fraud. So if I was him, I'd be doing a contains. I would not be doing a FreeText because I want the word fraud. And maybe I would include the thesaurus where I put in some common misspellings and told it to treat fruad the same as fraud, or fradu or something like that. Other than that, but I would say for the most part, in most scenarios, I would be using FreeText most of the time, unless someone said, no, I only want that exact word, or I only want that exact word or these common misspellings, where I would use the thesaurus and treat them as the same word.
Is there a performance difference between the two?
I suspect there is. In my small data set, I can't detect it because I was playing with that earlier, and I suspect that the FreeText must be a little bit slower. It has to be, right? Because it's searching for different kinds of words.
More features, yeah.
Right. It has to be. But I wasn't able to detect it in my little data set.
Got it. Thank you.
So you said that this is kind of an old technology, kind of a forgotten feature from SQL Server. I don't hear a lot of full text. So in today's projects, I think my question is, do you see this being used, or other types of dictionaries such as Solar or any other technology on projects?
Yeah. I would say that the nice thing about full text indexing is that you already have it. It's already probably installed, or could be easily installed, and you can see that you can be up and running on it in no minutes. That's what it has going for it. It's not super powerful. I see far more folks, if they have time and they have the inclination and they want to build something that's more powerful and does things like autocomplete and suggestions and things like you're used to on a Google. They use something like an Elasticsearch. That seems to be most popular. That's what I would use if I was going to do something like that myself. But again, this thing you can be up and running in no time. That's the only thing I see as its real pro, is that it's fast and it's contained in SQL Server. You don't need a second box, or even if you run in a container or something, you don't need that second item on your network. That's really the only great thing that it has, in my opinion. I'm embarrassed. I'm struggling. I can't find the answer to that and how I would escape the word near. You know what it would be? It would be quotes. What am I thinking? Of course, it would be quotes. If you wanted to find the word near, you would put it in quotes, and that means the word near. I feel a little silly. So it doesn't like in the word near. I would need like a tilde to say I'm searching for 3 words. And now I'm searching. Let's see, does that go? There it is. And of course, nobody has amount and near and threshing in my example, but that would search the word near as putting it in quotes. That's how you would escape it. Let me get back to that chat. See what else might have come in. How would you do thank you, Ashish, for the comment there. And Jonathan, how would you capacity plan? So the space for that is going to be probably in the same line with the number of, or it's the same text. It's going to take the exact same letters and just barf them into this table, right? So I suspect that however big your table is, minus the columns you're not bringing, right? It's going to be that big. And so if you got a 10 gigabyte table, I would suspect I'm going to have a 10 gigabyte catalog. That's what I would plan for storage. I would plan on however big my table is, however big my table is going to be. That's how big my catalog is likely to be. I don't know that it does anything like a compression, maybe a little in some hash tabling or something. I don't know what it does under the hood. But I've always planned for, hey, 10 gigabyte table, 10 gigabyte catalog.
I would think that it has less because it has words that it knows to get rid of.
That's true. Noise
get
words.
rid of all the all the articles as well. So I think it's probably less.
Yeah, you're right. It would be a little bit less. So what Steve's mentioning is noise words. It doesn't bring a, and, the, and, or things that mean nothing. So you're right. It would skip all of those words. So that would bring it down a little bit. Some of that'll be erased by the fact that it's going to keep track of some level of its location in the text, but probably not all of it. So yeah, maybe a little smaller. I don't know what that percentage might be. I mean, 10% smaller. I wouldn't think it'd be a lot. But you're right. It doesn't bring in the periods. It doesn't bring in the commas and the semicolons. So certainly it would make that text a little bit smaller in that way.
I think another advantage is not only that you don't have to spin up any new services, is that the full text search is already included in the price of SQL Server.
Yeah. I say this. I think Elastic is free. I think it's an open source freebie. Your machine wouldn't be the separate machine. You would have to have licensing costs to bring that machine up and hardware costs. So yeah, the fact that it's free, it's a matter of if you've already installed it, it's a matter of right-clicking to start a service and using it. It's quick, it's easy. That's really where I think its value comes in. Yeah, it's totally free. It might even be in, I don't know if it's an Express. I don't know if it is or not, but it might even be an Express.
Elastic is completely free?
I thought it was free. Isn't that an open source?
Yeah, but I think they changed the licensing to fend off AWS. And that was 2-3 months ago. And AWS decided to do their own Elasticsearch.
Oh. So I haven't looked in a while. It was free. Now it says here, Elastic.co, free and open search. The creators of search petabytes of data, blah, blah, blah. I don't know. The tagline when you Google Elasticsearch is it's free. Now it says there's a pricing tab. So what does that mean? So they're saying $16 a month on Elastic Cloud. So they'll host it for you for $16.
No, $16 is nothing. Yeah.
But it's it's so they have a free and open license. So there is a free and open license that I presume costs nothing, but it is extremely limited in features as they go. And then there's a bunch of other ones that cost money. So you can get a super basic version of Elastic for free. But it's I think they added a Windows version. For many years it was a Linux only. So if you were a Windows shop, you had to make one Linux VM, figure out how to install Elastic on it. It was a whole to-do. It's gotten popular enough now, and I see they got some hosting options. I would think it would be easier to install than it was, 4 or 5 years ago. But it's going to be a thing. You're not going to be up and running 10 minutes from now the way you could be in a full text index.
In terms of memory footprint, how much would you recommend to leave RAM? So let's say if I have a machine of 50 gig and I give to SQL Server, let's say 40 gig, how much full text search would you think is going to consume or take?
The actual service isn't that much, and I think the most of the RAM still sits in SQL Server. Just the service is just scanning the data inside a SQL Server. Let's see if I don't know if I can get. Let me see if I can get a number. What's mine doing right now? I don't think it uses very much, but it's going to start chopping away. You would want to add more to SQL Server, I think, is where we're at. So let me pull up my my list. Do a resource monitor. Let's see what he's doing now. I've been searching him a little bit. Does he use any RAM at all? Here's my CPU. So we have. So there's SQL Server. What is the actual executable for that?
Do you know if it uses the buffer cache of SQL, or it's a different memory broker for full text?
So I don't know for sure. I don't recall seeing a buffer for full text. Like I've seen the list all those times. I feel like it would jump out at me and I'd remember that. So I think it just sits in the buffer pool. But it's a great question. I don't know. Okay, it's fd launcher.exe. So do we have an fd launcher.exe running up here? Fd launcher, move them up to the top. So he is using, oh, it's a CPU. I wanted to see his RAM. Right, so he's using all of a meg here. So I think that thing is just scanning the data that sits in the catalog. I don't think that it is using its own RAM. I don't think it stores that catalog in itself. So I think it's all just in the buffer pool. If we go do a select from like one of these memory clerks or one of these, right? Select star from sys.dm. Oh, actually, you know what? I have it open on one of these, right? If I did one of these, just do like an OS performance counter. Let's see if I don't know that there's a separate item for that. I don't know that any of these say. Let's see, is there a separate counter where counter name like full scans? So there's nothing for full text as a counter name. Is there one an object name? Yeah, so there's not a separate performance counter for it. I don't think there's a separate memory clerk for it. I think it just sits in the buffer pool.
So Microsoft thinks this is insignificant use?
I've never needed to do anything. You know, I've used it a few different times. Never anything super huge though. Like I don't know what would happen if I pointed it at like the Library of Congress. I've only ever pointed it at smaller items, and it's always been inconsequential for me.
Got it.
OS memory pools. These are all OS.
It's a memory clerks, right?
Is it here or am I passing? Where'd it go?
Yeah, bro. Yeah.
Okay. Here we go. We want to look at. We're looking at anything in type. We want to see if it's in type somewhere. Okay. Oh, here we go. So we have some full text. So it does have some items.
Yep.
And again, for this, it's inconsequential, but I don't think it would be inconsequential all the time. But there you go. It has its own items. I'm trying to think where I use that the most, so I could go get an idea. If we have a minute, I'm going to go open up a different laptop and go to a server that uses this pretty significantly and see if I can get a number. I don't know if I will or not, but I've got one in my work laptop that none of you can see. Okay, we'll run that query from sys.dm OS memory clerks. Where type like, what's it doing? Percent full percent. Okay, so this guy runs a pretty significant amount of searches, and he's at 296. So where we have is that client default. Let me see what number that is. Net default. So. Cache store 32. Yeah, that's about the same. And then this number here, where it's 128 on my server, it's 296. And this is a pretty active server that does a lot of full text. I mean, I assumed it did a lot of full text. I'm a little concerned maybe they don't. But yeah, it's pretty insignificant in that environment.
So which means if the full text index is installed by default, it's not going to change anything.
No, and it's one of those things like I've always sort of told folks, you should, if we're not using it, we should turn it off. But if you ever been like, wow, I'm running out of RAM, we better turn off this full text, never, right? It's never been like, it's never eaten a bunch of RAM. We saw it on my system here. It's using nothing. Yeah. It just kind of sits there idle. Probably other than when he's actually building an index, he's just sitting around. I think he really is just brokering those calls. He's just saying, look, I'm going to you come to me, and I'm going to go right back to in the buffer pool and look at my data and come back and give you results. That's really all it is. Looks like we got a nice turn. I'm looking at the list. I haven't seen the list. We got a nice turnout. That's great.
Yep. As Elena, who is a co-leader of our group, the Large Data Platform group, she shared a tiny URL link. This is a link for T-shirt raffle. So please click on it, put your name, and we'll be raffling one person to get a T-shirt or user group T-shirt. It's a custom T-shirt. So you can decide the size, the color, basically most of the stuff the way that you want it. It's a great presentation. I didn't know about the table stuff, and I think I only use FreeText.
It's the far more powerful search, certainly.
And I was shocked to see that once I bring back results for fraud and I flag them as fraud, I didn't realize that I have to accommodate for not fraud.
Yeah.
So that was discovery to me.
Yeah, luckily that's interesting. Yeah, because you'd be searching for the word fraud. You should really almost like spell fraud backwards when it's not fraud. Like, can you just make it DUARF when it's not fraud, so I don't accidentally think it is.
Yeah. Except that the system is used for about 5 years with customer service.
Wow.
There's pretty much nowhere to go with that.
Sounds like it.
Yeah. What is the alternative of full text search on the Azure platform?
They have a thing. Gosh, what's it called? They have a product that is certainly it's more of a direct. It's less of a direct competitor to full text and more of a direct competitor to Elastic. But yes, they have a. I'm trying to look it up real quick. They have a tool that they sell. Azure Cognitive Search. Well, it looks like they added full text search to Azure SQL database, so you can do full text on your platform as a service. But yes, Azure Cognitive Search. That is the one that it says here, formerly known as Azure Search. That's the guy that would compete with an Elastic search that you might use. And
can I get this full text search? Can I get probably not, but can I get an idea of the, let's say, of the feedback being negative or the feedback being positive?
You mean from the people that use it?
No. So let's say I have a feedback column, and I'm trying to identify how many people responded with, let's say, good product and how many responded with bad product. Obviously probably would have to look for good and bad, but could that be sophisticated to detect if this is positive or negative? Or I would have to type all the words.
Yeah, when you were starting to say that, I started thinking to myself, even like the free text, it's not going to recognize that good, great, awesome, and wonderful all mean the same thing. You could do that in a thesaurus, but it doesn't do like a mood. That's something that I think you would probably find in the AI portion of like the Azure Cognitive Search. It's smart enough to do something like that, but yeah, you would have to try to figure out all the words you wanted to consider as good and hope they didn't have a not in front of them. Like it was not good, but you saw the word good.
Yeah.
You're making a point. It's a great point here that there's a lot of limitations to this, right? That's why it's not popular. And I use it, and there are reasons to use it. But for the things you really want to do that are really cool, and people start typing in an answer, and you suggest to them, the finishing your words like a Google or somebody does, it doesn't do any of that, any of those like modern things. And there doesn't appear to be any interest in doing it. Like I said, that the documentation that comes shipped that you installed, it might be sitting on your machine right now, still has IE5 and Windows 2000 as the suggested thesaurus items. They're clearly not putting any money into it.
Yeah, stepchild. Yep.
Mm-hmm. But I mean, if you want to find a word, you can see that it's fast. That's its big pro. It's big plus. You know, you can be up and running in no time. And if you're just trying to find some words like the word fraud, but also not fraud, you can be up and running in a few minutes, and it will do that and do it very well.
Yeah.
Yeah, we use this. I guess I use it for anytime I need to replace a search. Like we had a product that we had to, a previous project that we had to search certain names into a big HTML column. So instead of doing like and waiting 15, 20 seconds to return, using this, we got us in milliseconds. So that was a good solution for that problem that we had. So I guess that's what I've been using mostly. I mean, as far as use cases.
Yeah, we had one. I was working at an insurance company, and people needed to be able to type in their name on our website and find their policy. And the problem was that the name column was one column, first, last. It was one column. And sometimes it was first, last, and sometimes it was first, middle, last, and sometimes it was last, comma, first, depending on who typed it in that day. And they need to be able to find any of those words. So a full text index was the answer to that. You could type in your first name, your last name, whatever. I would find that word in the name column, and hopefully it wasn't John. That would be a problem. But if you typed in, a last name that was a little bit unique or something, we could try to find it, and we could try to find both, your first and last name using a full text. And we were able to help people find their policies. And the initial version, like you said, with a like. It was brutal. You couldn't do it. It was you couldn't get an answer. We had too many, over the years, the number of people that had held a policy were hundreds of thousands, and it was not a table you could scan looking for names.
Want to find out the storage, the space taken by the catalog in some of the extensive data sets.
I'm looking there. So if you're on the screen here, I'm looking. I don't see it listed as one of the tables, which I think we expected. There might be some other DMVs that give us some idea of the size. I'm not sure where I would look for that. Right, but it doesn't show up here as top tables. If it was the only thing in the primary file group, that might be okay. Let's see if there's.
Maybe it's dropping stuff into MSDB?
I wouldn't think so. Here we go. How to determine the size? I'm going to Google this. We're going to see if we get a real quick answer. And all right. Ooh, there's a DMV called this. Hold, please. We're going to get an answer. All right, we're going to come over here. I got to put it back. I deleted it because I wanted to see if it went away. So let me create the catalog and put an index in it. Give that a second. And then this guy, full index fragments. There it is. So that full index is 317K on a table that is 392K in size.
Okay,
that's
a
little
great.
bit smaller than the table.
Have we discussed the? Is there a way? Is there a concept of fragmentation? Like you're supposed to rebuild it. So how do we know at what point it would be necessary, as opposed to do you do it weekly? Is it just like a?
So you can count the fragments in here. Crumbs. How about I do that? So I only have the one fragment. So you're not going to get a nice clean percentage like you would on a regular index. But if you came in here, and this is obviously one fragment, which is nice and easy. But if there were many fragments with, especially some of them real small, it probably makes sense to go ahead and run that command to shrink them, shrink the count. And that looks something like, I have it in my notes over here. Read this off of books online, so you might do something like, my catalog is called. So I might do something like, if my fragment count got higher, there was some awkward size there, I might rebuild or reorganize. Assume I can reorganize it right now. You won't find much. So that's the command that would do a reorg, and you saw there was rebuild, and you would base it on. Yeah, I don't know if there's like a best practice. I found somebody wrote an article about that once, shared it on Twitter because someone asked me. Yeah, I just run like the reorganize every weekend. Probably a lazy solution, but I just run them.
Okay, this is great. Thank you so much.
Yeah. I've been to this presentation 4, 5, 6 times now, and you guys have all the best questions. Like all these things, I thought I've been asked every question. You're coming in with all the good ones. Good stuff.
Wonderful. Eric, thank you for your time. Attendees, thank you for spending your precious time with us, and we'll see you next meeting.
All right, guys.
Excellent presentation, Eric. Thank you so much.
Have a good evening.
Thanks, Eric.
You bet.
Thank
Thank
you.
you.
All right.
Bye-bye.
Bye.
Thank you,
Have a
Eric.
good night. Bye.
Bye.